In this lesson, we talk about another V-Ray light type, which is Domelight. Domelight is often used for image-based lighting or IBL. In this popular lighting method, you take a high dynamic range image or an HDRI and use it as your light source. So when you create a dome light, you basically have a virtual spherical or hemispherical light source around your entire scene. Then you assign an HDR image to that sphere or hemisphere, and you would get a nice beautiful lighting which is based off of the color and intensity information from that texture that you have assigned to your dome light. Let me quickly show you what we have in the scene here. First, we have this clock, this bottle, and these books, and also this plane object here. Also, I have a physical camera with depth of field enabled and the exposure set to 10. Great. Let's create our V-Ray dome light. From a V-Ray toolbar, click on V-Ray dome light and then click once in the viewport. Now we have created a dome light in the scene. Always remember that the dome light encompasses the entire scene and the size of its icon doesn't matter for lighting purposes. Now select the light and rename it to V-Ray underscore dome light. In the modify panel, the first thing you need to do is to define the texture you want to use with your dome light. If you go to hdrlabs.com/sib/archive.html, you can find tons of free HDR images that you can use according to their terms of service. Now go ahead and download this lobby HDR image and put it in the images folder of your scene assets folder in your project files folder. Now let's get back to our 3ds Max scene. In the modify panel of your V-Ray dome light, click on the texture button and choose V-Ray HDRI map. Now in the choose HDRI image window, select the HDR image that you just downloaded. So basically we are going to be using all the light and colors from this image to lit our scene. Perfect. Now in order to see the HDR image that we just added to our dome light in the viewport, we need to also define it as the environment map for 3ds Max. So open up the material editor by pressing M and instance the HDR image in the material editor. I know I'm going to be using a color corrected version of this map, so for now let's connect this map to a color correction map. Right click and from the maps, general, add a color correction map and connect the V-Ray HDRI map to this one. Now press 8 to open up the environment and effects window. Instance the map in the environment map slot. Okay, now close these windows. Now press Alt and B to open up the background tab of the viewport configuration window. Set the background type to use environment background and press OK. Perfect. Now we can see the map in the viewport. Before seeing any renders, let me select my physical camera and disable the depth of field effect for now. You can now take a render and see what we have. Now I'm going to show you the render in the frame buffer. You can go ahead and continue rendering if you want. As you can see, the lighting and our beautiful reflections are all based on our dome light. One of the first things you might want to do is to rotate your HDRI map or alter its brightness, and you can do all of that in the V-Ray HDRI map. So let's open up our material editor and also let me run V-Ray RT. We will be discussing V-Ray HDR map in detail later on, but for the time being, let's go over some of the most important options. First of all, using the horizontal or vertical rotations, you can rotate the map. So let's try 50 in horizontal rotation. Let's try 150. Maybe let's try a vertical rotation of 50. Maybe -50. Now let's change it back to 0. And let's also set the horizontal rotation to something like 250. Also, you can use overall multiplier to increase or decrease the brightness of your HDR image. Maybe let's try 3 here. Maybe 6. Now let's try something like 10 maybe. And finally, let's get back to 5. I think it would be enough for this scene. I really don't need all the color information from this map, so let's select the color correction map and desaturate it by 70. Now make sure it's the color correction map that the V-Ray Domelight uses and not the original map. Now let's close the material editor and stop the active shade. Select the V-Ray Domelight and see what are its options. In the Domelight rollout, we have spherical, which determines whether the Domelight covers an entire sphere around the scene, and if you disable it, it will only cover a hemisphere. Next, we got effect alpha. By default, it's disabled, and that means the Domelight won't affect the alpha channel. In the V-Ray frame buffer, if I select the alpha channel here, you can see the light isn't contributing at all to the alpha channel. Let's enable effect alpha and run the RT. And now, as you can see, the light is contributing to the alpha channel. Next, we have lock texture to icon. If enabled and I rotate the Domelight in the viewport, you can see the HDR is rotating in the render. So you can control the placement of your map this way instead of going and changing it in the V-Ray HDRI map. Let me zero out the rotation and disable this option and stop the active shade. Next, we have ray distance, which specifies the method of determining the maximum distance to which shadow rays are going to be traced. And this is the exact definition from V-Ray's help. When it's set to none, there wouldn't be a maximum distance. If set to GI, the maximum distance is determined by the GI settings. And if set to explicit, you can specify the distance using this distance value down here. Now, let me show you two renders. In one, the distance is 5 and in the other is 100. Let's see how it affects the shadow rays in this scene here. As you can see in the frame buffer, clearly the shadows are less visible in the version with distance set to 5. Now let me change the ray distance method to none and untick effect alpha and lock texture to icon. Then we have photon emissions options, and these two options are for when you have caustics enabled in your scene. Target radius defines a sphere around the light icon where photons will be shot, and emit radius defines a sphere around the light icon from which photons will be shot towards the target radius area. Now we're going to be discussing caustics definitely, and I'm just going to explain these options very quickly because we haven't talked about caustics yet. Let me just quickly show you how these radii affect the caustics. First, we need to enable caustics. So in the render settings window and in the GI tab, enable caustics, and just to see the effect clearly, let's set the multiplier to 30. Also in the V-Ray tab, set the image sampler to progressive and limit the render time to 1 minute. If you go ahead and render the scene, you can see after the GI calculation, we have an immediate result, and it is refining as the time goes by. Now let me just stop the render and show you 3 renders that I have with different target and emit radii. Also, there are some viewport representation for target and emit radius. You can see these 2 green hemispheres in the viewport, and as I change these values, they get updated. In the first render, target radius set to 5 and emit radius set to 7, and as you can see, we practically don't have any caustics in the scene. In the second render, let's set the target to 17 and emit to 22. And now we can start to see the caustics effect. And if I take a look at my top view, you can see the green circles or hemispheres aren't completely encompassing our clock and books, and you can see that translates into our render as well. If I come here and increase the target radius to 100 and emit radius to 150, you can see now in the top viewport we have the green circles encompassing our objects completely, and this is the render you are gonna get. Now, as you can see, the caustic effect is quite visible, especially inside the clock, as you can see. Let me go to the render setting and disable caustics for the moment. In the advanced option rollout, we have use MIS or multiple importance sampling. Let me go to the material editor and select V-Ray HDRI map and click on the view image button. You can see in this image we clearly have darker and brighter values. Some sections are emitting more lights and some parts are darker. When MIS is enabled, or multiple importance sampling, V-Ray will trace more rays in the direction or directions where the light is coming more strongly. You really don't need to change these options, and you'll be better off leaving this option alone all the time, but let's see a few render comparisons and see how it might affect your renders. First, go to the render setting and limit the render time to 3 minutes. In the render elements tab, let's add lighting, global illumination, and reflection passes, and press OK. These passes are essential to see what exactly MIS and multiple importance sampling are changing when it's enabled and disabled. Let's go back to our frame buffer and see 2 renders with and without MIS enabled. The first render is with MIS enabled, and in the second one it's disabled. As you can see, the results are very different in this particular scene when the entire lighting is coming from one V-Ray dome light. You can see we get noisier reflections, some fireflies or these very bright pixels here and there. Also, if I go to the other passes like global illumination and compare the two, you can see they have different information about the lighting. And the same thing goes for the lighting pass as well, and the reflection pass. As you notice, the lighting information is distributed differently between passes when MIS is enabled compared to when it's disabled. And now, as I mentioned, just don't touch this option and let it be enabled unless you know what you're doing. Let me turn on use MIS again and close the frame buffer. Now let me select the physical camera and enable depth of field. As you can see, my aperture size is set to 6, so we are gonna get a very shallow depth of field. In the render setting window and comment tab, let's set the output size to 1600. And in the V-Ray tab, change the image sampler to bucket. Let's set the max subdivision to 24 maybe, and noise thresholds to 0.01 and change the bucket width to something like maybe 32. This is basically the size of the buckets or squares that you see them when you render your scenes in the frame buffer. In the GI tab, set the irradiance map preset to maybe medium, and low possibly would work in the scene just fine, and the light cache subdivs, let's set it to 1000. And in the render element tab, let's delete lighting, global illumination, and reflection passes, and add V-Ray denoiser. And let's change the preset to something like mild. You can go ahead and render the scene. In my case, let me just show you the result in the frame buffer. So this is our final render. And this is our V-Ray denoiser pass. Let's make some quick color corrections in the frame buffer. First, enable the white balance and set temperature to maybe something like 7000. Enable color balance and make the shadows a bit bluer, maybe something like 0.16. Also enable the highlights and make them a bit warmer, maybe something like 0.08 or 0.1 would just be fine. Now let's add some contrast using curve section. Now you can go ahead and save the result with JPG or PNG, and the color correction that you have done here would be saved. I might go ahead and do a bit more color correction in Photoshop or After Effects and save the results there too. So in this lesson we talked about V-Ray Domelight, and I will see you in the next one.